Good morning. So today, for day 3, we're going to study the law of sines. It can be used to find a side. So what you'll notice, you'll have the angle followed by an angle side. Sort of like in this picture here, for example, 1. Angle, angle, side. Now, obviously, you can find angle A the old-fashioned way. If you remember to add 141 plus 29, that's 170, and take 170 and subtract that from 180. So obviously, the good old days of geometry, you can still find the missing third angle. That's not the question. Sometimes they'll ask you to solve for all missing parts, and that's a breeze, right? But sometimes they want us to find this missing side here. So we need to use what's called the law of sines. It turns out there's a nice relationship between the opposite side and the opposite angle sine. You don't use all 3. What you need to do is pick any 2 of these. So yes, you're going to set up a proportion and cross multiply. Students really enjoy the law of sines. In fact, some of you might already are familiar with the law of sines because your Common Core geometry teacher may have taught this instead of SOHCAHTOA or along with SOHCAHTOA. So here's the other thing too. You can also use this relationship to find a missing angle. Now, it does spell the naughty word angle, side, side. So tomorrow, we'll talk about something called the ambiguous case, because sometimes this leads to a situation, because we know an angle whose sine in quadrant 1 is angle the same angles, using that angle as a reference angle. So like for instance, the sine of 30 degrees is 1/2, right? So too is the sine of 150. So we'll explore that more so tomorrow. But today I just have 2 examples using the law of sines. So example number 1 states, we have a missing side here. So they want us to find the length of AB. Now AB in relationship to angle C, this is side C. So C over the sine of angle C is equal. Now we need to pick an angle and an opposite side. So we do have this angle on this side, so let's use that. So we're going to use B over the sine of angle B. And it's not necessary for you to write this out, but I am, since I'm assuming it's a beginner for many of you. So we're going to have here C over the sine of 29 degrees is equal to 48.2 over the sine of 141. Now don't solve for any of them, cross multiply, so C times the sine of 141 degrees is equal to, now I usually put the side in front, remember multiplication still is commutative, 48.2 times the sine of 29 degrees. And again, don't solve for anything yet, show my work, whatever this decimal is, I'm going to divide both sides by this decimal. Again, use your calculator. Check the mode. The mode should be in good degrees. So we're going to take 48.2 times the sine of 29 degrees. And we're going to now divide by the sine of 141 degrees. And this is the answer we get. I don't see any provisions for rounding, so let's do 3 sig figs, 37.1. You don't have to write the units down. I mean, if they do give it to you provided, let's say centimeters, go ahead, but you don't have to. And that's example number 1, using the law of sines. Now, the only thing I can think of where they can make it a little bit more complicated, they might say solve for all missing angles and sides of triangle ABC. Sometimes the directions just state solve triangle ABC. And then you're like, your hands are up and you're like, what do I do, right? So if you see something as simple and as little as solve triangle ABC, they want everything that's missing found. So you have to use some algebra and trig. So what do we do first? Well, I see angle, side, side. Okay, that spells the naughty word, but I do have this side here, A, and angle A. So we're going to begin with A over the sine of angle A. Hey, we do have side C, so C over the sine of angle C. And if I fill in what I know, 24 over the sine of 50 degrees is equal to 22 over the sine of angle C. So my plan of attack is I'm going to find missing angle C. Oh, no, Kitty, you gotta, okay. So if we cross multiply 22, the sine of 50 degrees is equal to 24, the sine of angle C. We're going to divide both sides by 24. And then we're going to use the calculator. We're going to get a decimal. That's okay. So we're going to get here 22 sine 50. Now, if you don't put the time symbol, guess what the calculator assumes you want to do here? Multiply. Divide by 24. And you should get a decimal that falls between 0 and 1. That's reasonable. So I'm going to write that all down. 0.7022. 0.7406. Okay. Peanut wants again the action here. Peanut. Okay, now she's she should be just taking a nap right now. That's what cats like to do. Okay, sine of C. So that's the sine. We want the angle C. So remember what I mentioned yesterday? If you hit second sine inverse, it wants the decimal. You don't have to type this over. I don't recommend doing that because if you're like me, you might make a typographical error. So second negative sine. Close the parentheses. It doesn't tell me what to round, so let's do 3 sig figs. So I get here 44.6. So 44.6 degrees is the measurement of angle C. So I'll go back here, 44.6 degrees. And now it's really up to what you would like to do next. Me personally, I'm going to use my geometry skills and I'm going to find the missing angle B by adding 44.6 plus 50 degrees, and I get 94.6. Subtract that from 180, so voila. So you don't have to use trigonometry every single time. If you remember, we did study a bit of basic geometry back in January, February. So the angle's solved, check. I do have a missing side B. So let's use law of sines one more time. B over the sine of angle B this time is 85.4 degrees. Now, what do you do next? I mean, in theory, you have this and this, and this. Use the given they recommend. So 24 over the sine of 50. Now, once you get the hang of doing this, some of you might say, hey, I know I'm going to multiply this and divide by that. Wonderful. I'm just going to show the work. So B, the sine of 50 degrees, equals 24 of the sine of 85.4 degrees. And I'm going to divide both sides by the sine of 50 using my calculator. And I should be able to get an answer here for B. So 24, the sine of 85.4. When I divide by the sine of 50 degrees, I get as my missing third side 31.2, which to me makes sense because angle B is the largest angle. So this side here had to be bigger than 24, which it is. Just as, see this 22? 22 is the shortest side. That is the smallest angle. So everything justifies, makes sense there. We'll see more tomorrow where, wait a minute, it's kind of wacky. How can I have the largest angle facing the shortest side? So we'll see that more when we study what's called ambiguous case, more of the law of sines tomorrow. Go ahead, do the homework day 3. It looks like it's short. It's only 3 problems, but try your best. And again, use the law of sines. Thanks.